think we're right on time, so let's get started. This is your database in the cloud, SQL Azure. So if you don't know who I am, my name's Jason Follas. I work for a company called Partitioning. I have an office a couple miles from here. I happen to live and do most of my work down in Toledo. So while down there, I run a user group, the Northwest Ohio.NET user group, which is the equivalent of the MI gang, which meets here at this location. I also like motorcycles, so you might, in summertime, you see me riding. I like a couple other things too. Most recently, I've gotten into running and fishing and fun stuff like that. But most of my time is spent doing this thing. So you're here at a Windows Azure event to learn what Azure is. So in order to talk about SQL Azure, let's just set some baseline about what Azure is in general. So here's a traditional data center, right? It's got lots of racks. It's got a little guy that runs around and looks at all the computers and whatnot. They have to put fire suppression, air conditioning. A lot of things goes into building your own data center. This is what an Azure data center looks like. This is the one that was in Chicago. Very different. It's full of all these shipping containers, all these fourth generation data centers. And really what they are, they're a data center in a box. And they come to the site on a truck, they get plugged into water and electricity and network, and then you have all of the computers inside ready to go. And inside, you know, there's a very narrow hallway in here, and it's just thousands and thousands of headless computers. They're not intended for a human to go in here and interact with, like the traditional data center. These are intended to be managed by software, so that if a hard drive goes bad on one of these machines, the workload that was intended for that machine is just sent to another one, and that machine's taken offline. If enough of these machines go down, and the container is just, everything that's in that container is then taken offline, moved to another one, that container goes out on a truck, the manufacturer repairs it or whatever, sends back another one. So that's how the new fourth generation data centers work. Does this remind you of anything, by the way? So the thing that makes it all possible is Windows Azure. That's the operating system that everything runs on. A little bit of confusion with the Azure name because everything seems to be called Azure, but Windows Azure is Windows just running on all of those machines that you see. And it includes like this fabric, this concept of a fabric, where that's the Borg concept, right? That's where it's aware of the status, the health of all these nodes that are running, and it's able to make decisions about if something new's coming in, it's going to go over here. If something over here is misbehaving, we need to shut it down and move it over to here. Those things are all automated by software, and that's why the Chicago data center can have thousands and thousands and thousands of machines, but only a couple people managing those whole things. Very different scenario than your traditional on-premise data center. When Azure first came out, the concept of the database in the cloud was more like what you see with the table storage today, if you're familiar with what the table storage is. It was just a set of RESTful services and a loose parallel to what SQL Server was. The customers gave very clear feedback that if they're moving applications from on-premise to the cloud, they're going to need some form of SQL Server in the cloud so that their application code still works. And that's where SQL Azure came in. Everything in the cloud is as a service, you know, storage as a service, security or identity as a service. Well, this is your database as a service. Let's look at how a normal database works, normal SQL Server. Your application connects to the server, and then you have multiple databases running on the server. That's pretty typical for SQL Server today. If you need like the hot backup or some kind of failover support, well, you just mirror one server over to another one. That way, if one goes down, you can just have your application connect to the other one, either automatically or by changing connection strings or something like that. With SQL Azure, it's a little bit different. Your application is connected to a service, which is just a facade. It's faking you out. It's not really SQL Server that you're connecting to, but your application really doesn't know. It thinks it's connected to a SQL Server. Behind the scenes, your database, if you create a database in SQL Azure, your database automatically gets 3 replicas. You know, that's kind of the same concept we're hearing all over the place, is that everything stored in SQL or in Windows Azure or Azure storage gets 3 copies of it automatically. And they do that for failover. So if one of these databases, the server that it's on, dies, while you still have 2 copies out there, they can redirect traffic to another one while they're rebuilding that third one so that you always have 3 available. In reality, it might be something like this, where those databases are not on the same machine. And ideally, you don't want them on the same machine. You don't want them on the same machine. You don't even want them on the same container. Because what if the roof collapses and it takes out one of those shipping containers that we saw? So your database is going to be scattered all over that data center. And the function, or the purpose of the facade layer there, the service layer, is to route the traffic. So when your application needs to connect to a database, it hits this service layer, and that service layer does the traffic forwarding behind the firewall. So how does it work? Your application and tools usually use some kind of library, ODBC or ADO.NET, and they talk to something called using TDS. TDS is the protocol that SQL Server uses over the wire. So this is tabular data stream. So that endpoint that I showed, that vertical line, is the SQL Azure server. You'll see in a second that you create a server tied to your subscription, and that's your endpoint. And the server is what talks TDS to you, to your application, so your application doesn't know that it's connected to SQL Azure. And then behind the scenes, it talks TDS to actual commodity SQL servers running in the data center. But the server part here handles the connection routing and handles the billing and provisioning. All of that's done through this server. Behind the scenes then, you have multiple commodity servers, server hardware that I showed in that shipping container. And some of those are running SQL Server. And then your database, when you start up a new database, or create a new database, it will be placed into one of these actual SQL servers that's running there. But like we saw on this slide back here, you don't know who your neighbors are. So, I could have a database, Jeff over there could have another database running on the same server hardware, but we won't be able to see each other's because of the way that security is configured. Everything is locked down by default. I never have a system-wide login that can access anything else on that machine. I can only access my own databases. And then the infrastructure is beyond that. So this is where once I define a server, I can then create a database or 2 databases on that server that my application will use. Yes?
Go back to the previous slide for a second. With the section where we have ODBC and ADO.NET, is it safe to say that Entity Framework would also fit in there?
I would say yes, because Entity Framework I would put into the tools. So the question was, I'm showing ODBC and ADO.NET here. Would Entity Framework fit in there too? I see Entity Framework as sitting on top of ODBC or ADO.NET, where those are your data, your infrastructure layer. This is Entity Framework would be at the application layer. So where you see tools, that's probably, or applications, that's where Entity Framework would fit in. So what are some scenarios where you might consider using SQL Azure? The 4 basic ones that come up, the first one's the departmental applications. So if you are in a small department, you need to stand up an application quickly, you don't want to go through your local IT, maybe it's too much of a headache, you have to fill out 14 pieces of paper and then wait 30 days. SQL Azure really gives you velocity because all you need is a credit card essentially, and you can bypass that. Now there might be some political fallback for bypassing your local IT, but the point is that you can go home and still stand up a SQL server in the cloud without involving your IT, and then just point your application to it. So web applications, small business or startup that need the cloud as their IT. So if I'm starting up a startup and I don't have thousands of dollars to spend on servers and whatnot, and I'm looking at the cloud, well, what's the database in the cloud? That's SQL Server. So that's the scenario there, that as I'm spinning up or using Windows Azure as my infrastructure, SQL Azure becomes my database infrastructure. ISVs, if they're hosting, I had an interesting conversation last week at a conference where the the person was talking about one of their customers. He was a consultant as well, talking about one of their customers who had just an application that was rapidly growing. They were adding more and more customers all the time, and as a result, they had to keep creating these SQL Server databases, but they were making so much money that they don't, the conversation of table storage versus SQL Server never really came up because, they were making money from this, so they just needed to be able to provision these SQL servers fast enough, and that's why SQL Azure was perfect for them. Instead of buying hardware to host on their own and spinning up as these new customers came in, they can just partition almost dynamically in the cloud as more and more customers came in. And then Data Hub is the final scenario I identified here. This would be using SQL Server in the cloud, so SQL Azure, as an intermediary between different locations. My company wrote a piece of software for Toyota. So Toyota a few years ago had an issue with the accelerators, if you remember. People were saying that the accelerators in the Priuses were sticking and they were getting in accidents. So inside Toyota cars, I don't know if all of them or certain ones, there's like the equivalent of OnStar, where if you were in an accident, then a message gets sent over the cellular network to a provider, and then an operator can come on and say, do you need assistance or something like that. So they were getting telemetric data from the cars, aggregating with whatever their source was, but Toyota wanted to have a situation room, a map of the United States that showed all incidents in real time so that they could see, was weather playing a factor, where are all the crashes happening and all those types of things. But this provider that they're using to collect the data was also collecting data from, let's say, Mercedes and other car manufacturers. It wasn't just Toyota data. So they somehow needed their application to tap in to just the Toyota data. And they used SQL Azure as the hub there. So there was a sync service that ran on-premise at wherever that data center was that would just query out the Toyota data, send it up to SQL Azure in the cloud, and then the application could hit that Azure database. And in fact, multiple applications hit that Azure database. Even though those applications were running on-premise at a Toyota center, they were able to get just their data because SQL Azure became the hub in this scenario. You might think, how expensive is this going to be? And recently, Microsoft had adjusted the rates downward. We're seeing a trend now where all of these cloud services are now competing against each other for customer base, and that's driving prices down, which is a good thing for consumers. So spinning up a database, if your database size is going to be less than 100 megabytes, it's just $5 a month is all that you pay. If it's up to a gigabyte, then it's $10 a month is all that you pay. And then after that, we get into the step function, where for every gig past 1 up to 10, it's $4 per gigabyte. And then 10 to 50 is $2 a gigabyte. 50 to 150 is $1 per gigabyte. And these are step functions. So that, let's say that I want to define up to 5 gigabytes or 6 gigabytes or something like that. So I would have to pay the $10 for the first gigabyte, and then I need to pay $4 per gig for the additional 5 gigabytes to make it 6 total. And that's by consumption, so that if I only consumed 4 out of those 6, then I'm only paying for 4 gigabytes, but it's the next highest threshold, if that makes sense. So the maximum database size that you see is 150 for one database. So that comes out to $226 a month. So if you're trying to go for a budgetary number, the maximum per month for 150 is $2.25, essentially. So that gives you a rough idea as to where you sit. Nothing's free, but you don't have the downside of purchasing hardware up front.
The size is per database, or like you can have multiple instances of the database within the given size?
Your build per size used. So even if I partitioned out and say that I want my database to be capped at 50 gigabytes, but I only use 2, then I'm only paying for 2 gigabytes.
Next question is,
Okay.
in your example for 16 gigabytes new, right? Can you opt for 2
You're charged individually per database. So however you mix and match it, they're evaluating your consumption per day and give you a daily rate. So that $10 a month or whatever is separated by your daily, or whatever. And I think by economy of scale here, the more you consolidate into one as you get larger, it's going to be cheaper than if you separate it out. So the rest of this talk, we have around a half hour, 40 minutes or so. The rest of this talk, let's look at some details about SQL Azure from a developer's point of view, and somewhat touching on to traditional DBA type of roles. So the first one is provisioning here. And we'll just come out and get right into it. So provisioning is done through the portal, or easiest done through the portal. So you would sign into the portal using your live ID that the subscription is created in. And in the portal on the left side, you see that there's a database node down there. So I'm going to click on there, and that pulls up information about all the databases that I currently have. Now I'm interested in creating a new one, so I'm going to create on the subscription because I can have multiple subscriptions listed here. And I'm creating a server first because you need that server, and then you add databases to the server. So when you create a server, it asks you for the region. And at this time, the only US region that's open is South Central. So you ideally want your servers to be close to where the application is running. So especially if you're on-premise or running an on-premise application that's accessing SQL Azure, you probably would want a US server. If you're hosting an application in a European data center, you probably would want to create your server, your SQL Azure instance closest to where that data center is. Here I'm creating a user. This becomes the admin of my server. It doesn't have like DB server admin rights, but it has almost the equivalent for just my databases on that server. Now notice the password rules here. You do need 8 characters. You need to have 3 of the 4, and that's an uppercase, a lowercase, a number, and a non-numeric. Any 3 of those 4, and a total of 8 characters. Plus, you can't have any 3 consecutive characters of your username. So they're pretty strict about what your password rule is. So let me come up with a password. All right, password is 12345. Now the next thing is, by default, nobody has access to this server through TCP/IP. Everybody is denied access. You explicitly have to grant access to the server. So when I add here, this is a firewall rule. When I add a rule, it's telling me, for convenience purposes, the IP address where I'm coming from. So I'm going to have to create a rule with this IP address if I want to access it here from the server, or from this building. So if you create a rule and then you start working at Panera or you go home, you're going to also have to create a rule for those networks. The checkbox down here that says allow other Windows Azure services to access this server, by default, even applications running in the data center is denied access to your SQL server or your SQL Azure instance. So if you have something running in a web role in a data center somewhere, you're going to have to check this box in order to add a rule to allow services running in the data center to be able to connect to your instance. When I hit finish, now I have a data center, now I have a server up and running. And I think this is my new one. I should have changed the administrator name to something different. But you see here that the server name is really just garbage. It's just random characters. But the fully qualified DNS name is your server name, the random characters, .database.windows.net. And you're going to need that in order to connect to your database. So I'm going to create a database in that server now. So when I explode that new server over here, you see by default I get a master database. That's because it's SQL Server. You can't get away with not having a master database because that's where functionality goes. The difference is that this is a master database that only applies to my server that I just created. So if somebody else creates a database server through this portal, they're going to get their own master database. We can't use each other's masters. So to create a new database, I click on the server. This is the point where I hope that the network keeps up, because demoing an internet service without a network is kind of fruitless. I'm connected to wireless.
They have wire up
We'll give this a shot. I think Jeff Fansler just screwed me up here. All right, I'm going back to wireless. In the meantime, I do have some slides, I think, that capture the screenshots. Woohoo! And we're back, as Twitter would say, or Gmail would say. All right, so now I'm creating a new database in this server that I created. So up here, you'll see that I now have a create button that's enabled for the data to create a new database. And I have a couple options here. For the addition, I can choose web or business. And then if I choose web, I'm restricted to just 1 gigabyte or 5 gigabyte size. This is maximum size. And as I said earlier, you're not charged for your maximum database size. You're charged per consumption at certain stepping thresholds. But the maximum database size will just not let you write any more data to that database if you reached your threshold without expanding it. So you can still read from it. If I fill up all 1 gig, I can still read from it, but if I want to insert more data, I'm going to have to upgrade to the 5 gigabyte plan. And for the business edition, you have a few more options. You have in 10 gigabyte increments up to 50, and then 50 gigabyte increments up to there, all the way to 150. At this time, there's really no benefit difference between web and business. It's just the maximum database size is the only limitation, or the only distinction. Now, the rumor is that in the future there might be more services or benefits given to business, and there might be less for the web. But at this point, it's just purely the maximum size that differs. Switching back and forth, I don't have an answer for that. For if you could switch, the question was, can you switch back and forth between web and business? I think you can always go upwards, and I just don't have an answer for that right now. And then I can test connectivity. So this is testing to see if I can establish connectivity to that server, and in this case, I can. So the server's up and running. I can connect to the database. From this management console, there's also a Silverlight application. So let's say that you're at your corporate network. You went around your DBAs. You created this database in the cloud. Now you need to manage it. You need to write queries or execute scripts or something. And for whatever reason, your IT has blocked the port 1433, so you can't access your server in the cloud from your corporate network. This is one way that you can do it. This is an application where you're communicating with services to a server that's running in the data center, and that server is then able to talk 1433 to your thing. So this is kind of like proxying SQL Server stuff. And what that looks like, we'll go on because I'm not trusting the network at this moment. So you log on here, and then it comes up with, this is the management portal view of the database, where you can come into this screen and be able to create new tables or create new views, procedures. You can run queries right from this Silverlight-based application. All right, well, let's move on. So the development story. Development story is going to be pretty much just like your on-premise SQL Server, except there's some differences. Bear in mind that because your database could be on the same server with other customers' databases, and in all likelihood it would be, they can't give you access to the file system. They can't give you access to other databases on that same server. So in order to protect other customer data as well as your data from other customers, they have removed some features that would depend on having access to the local hard drive and things like that. So there's a list of things that are not supported. They're detailed online. I'm not going to talk to all of these. I'm just going to slowly advance through these slides so that you can admire all of the bullet points that detail the things that aren't supported. But most of these you'll see are related to having the need for the SQL Server to either access all the databases that are on the machine, or to have access to the drive or things like that. One thing to note on this screen, the common language runtime is not, XML data type is supported, but you can't create indexes, things like that. So some of the feature set that you might be used to in your on-premise SQL Server are partially supported in Windows Azure. And in T-SQL, so just a list of features. So consult the documentation as you start developing. And in a little bit, we'll see that there's a tool that will help when you're migrating. If you're migrating a database from on-premise into the cloud, there's some tooling that might help you to detect if you're taking advantage of a feature that's not supported, or help you create scripts that don't include those features. So when you connect to the database, when your application connects to your database, you're connecting on TCP/IP port 1433 only. And we already saw where I have to create the firewall rule, so we have to explicitly grant either specific IP addresses or blocks of IP addresses, a start and end address. And then if your machine is not in that block of addresses, it will be denied access. SQL Server authentication only. So this is a SQL login. Obviously, it's not running on your local network. It doesn't have access to your Active Directory or whatnot, so Windows authentication is not supported. The login name, sometimes some APIs don't recognize if I just put like login. I would have to put login1 at and then my server name, that cryptic random address that was given to my server. So be aware that you might need to use alternative name if the short one is not supported. The use command databases is not supported. And that's because they can't have you jumping to other people's databases, so they just took out the use command altogether. And strangely enough, even though Microsoft was the big developer of OLEDB, and OLEDB was set to replace ODBC and all of that, OLEDB is not supported for SQL Azure. So your two choices are the ADO.NET provider and ODBC. Those two things are supported, but OLEDB is not. And then if you add this bottom line to your connection string, it'll encrypt the connection so that the traffic, the TDS traffic sent over the wire, is encrypted. Now, all of these things that I said were not supported. You can get a status, you can make a recommendation for getting them into the product, and you can see a status of how other people have, or the status of previous recommendations from a website called migrateSQLAzureIdea.com. If you go there, it's a normal dig type of voting site. You make a recommendation, people vote it up, and then the product team comments on it. Now, most of the evolution that we've seen in SQL Azure in the last couple of years came directly from here. So people have indicated that they really need this feature. The product team, in a lot of cases, have just built that feature. They use this as their priority type of list. So migrateSQLAzureIdea.com, you can get a status of all those features that I said were missing. All right, the next thing to talk about is how to design for scale. Now we're in the cloud. The cloud is known for having all of these commodity databases, and we hear this all the time that in the cloud we scale out. So on premise, if my database is becoming overwhelmed, too many people are hitting it or something like that, my only option really is to scale up. I buy bigger hardware, bigger disks, bigger processors, all of those types of things. So my easiest solution on premise is to scale up. In the cloud, we don't have the ability to scale up. We can spin up multiple instances, so we scale out. When we scale out, or when you take a database and scale it out, that's really called partitioning or sharding. That's the term that we call it. So let's take a simple customer ordering system here, a shopping cart system, an e-commerce system, where we have a customer, and the customer can look at a list of products, and he can put a product in the cart, and at the end of the cart, he checks out, and that becomes the order. So that's what he's purchased from the product catalog. So with partitioning, we can take this table, this customer table, and split it. We can say that, everything above this line is going to go into one database. Everything below the line is going to go to another database. And the databases are identical, aside from the fact that this group of customers, all of their data is enclosed in one database, and all the other customers are in another database. So this is sharding. This is what people talk about when they say sharding. It looks very simple on paper. It's not as simple in practice, because now you have to have your application aware of, well, if I'm dealing with customer one, what database is he in? How do I get information in there for customer one and whatnot? Notice that with the sharding scheme, orders, customer, cart, those are all customer specific, But product really isn't customer specific. It's just something that has to exist in all of the tables or all the databases because it's a common element. So with this scheme, we don't have a master database and then have foreign key relationships across database boundaries. So we have to replicate that product table into all of the shards that we have. What I already talked about, how does the partition, or how does the application know where its data is? One is to be aware specifically, so you know that if the customer ID is between this number and this number, it's in this database. And you might maintain a list of connection strings in your application that then dynamically routes to the database. The other one is called a fan-out query, and that's really where you send the same query to all of your database shards at the same time, and then some of them will respond with no data back, some will respond with some data back, and your application's role is to aggregate that data themselves. So in this case, if I'm looking for data for customer 4322, I send the query to everything, only one database replies. Likewise, same type of thing. So this is where I said that it's not trivial. Your application has to be designed to do this. So does your database schema. Well, you probably would do something like this, where you send the query to all of the databases, and then each database tells within its own customers how many of those customers bought that product. So you might get 10, 20, 30, 40 back as a result set, and you have to aggregate those in your application.
So if you had another database, you spread out again, you have to go back to your application?
Yeah, with fan out, yes. Yes, it complicates things. It solves the problem of sharing the database load across multiple servers at the expense of making querying into those a little bit more complicated. So to help you do the sharding, SQL Azure came up with something called federations. And federations really handles the infrastructure part. It doesn't solve the problem of fan-out querying. So let's show federations for what it is today, and then just know that it's something that continues to evolve. So my hope is eventually they solve the fan-out problem so that your application doesn't have to worry about it. You just send one query here, it fans it out and aggregates the results for you. So let me see if this is working again. So I'm trying to manage a server here. I can't do it, so I have to talk to slides. I apologize. No. All right, so I'm connecting to my database. In this case, the database is called Day of Azure. And up at the top, that box that's highlighted, that's the new federation. There's a tooltip that appears when you mouse over it. It says create new federation or something like that. So what I'm doing is I'm declaring how I want to partition my data. That customer table that I saw, how I'm splitting the customer table so that this set of customers is in one database, this is another. That's the concept I'm trying to define here. So when I create a new federation, the first thing I do is give it a name, and then I have to create something called a distribution name. And this is just this is basically assigning a type to something named. In this case, I'm CID because customer ID is kind of what I want to divide it on, and the type is really your numeric types. It's I think you can federate on like a big int in this case, or a unique ID, which is a GUID, or like a 900 character var binary. There's a specific list of things that you can split your data on, In this case, I'm picking big int because my data was based on a big int data type. And I hit save. And that creates a federation. So you see here that I have a customer federation that was created. When I click on that customer federation and look, I'm getting a view here. This might not look like much, but what I'm seeing is one database that was created for this federation. So it just so happens that all IDs or all big integer values would be placed into this one database as it exists. Now what I can do is I can then split this database. So I can use this to see if one of my shards is growing too big, and then if so, I can split that shard into two separate shards right from this screen. Now, once you create a federation though, into this federation, you need to put everything that has to be copied into the other ones. So by default, this federation is going to be empty. So it's just going to be an empty database. You'll end up connecting to that federation, that database, and then creating your tables, like that product table, the order table, the customer table, the cart table. All of those goes into this first federation member because that becomes your template then. So if you split this, let's say that it's growing too big, or it's one particular customer in general is generating too much traffic to it, and you need to split this particular one into two or more, then all those tables that were defined in it get copied into the new ones. So that's why the very first time you're setting this up, you do everything in this first one so that it's copied into the other ones. Now when you create tables, well, the first thing is connecting to a federation. So I said that you can't use the use statement to jump between databases, but they repurpose the use statement to connect to a federation. So in order to connect to that first federation that was created, I just need to provide a CID, that was the distribution name that I assigned. I have to provide a value that exists in that federation I want to connect to. And since all big integers are assigned to that very first federation, I can say CID 0 to connect to it. Or CID 100, anything would connect to it. Once I connect and I'm creating my tables, the create table looks like your normal ones. By the way, all tables in SQL Azure have to have a primary key. That's one requirement. So you can't have heap tables in SQL Azure. Everything has to have a primary key. But at the end of the create table statement, there's this federate on. And then you say your distribution key, which I called CID, and you assign it the column from the table. That's how it knows that, that all those ranges of customer IDs, which federation they get assigned to. And in this case, I've already started splitting up my federation, and I just clicked on that last one over here that says 100, and now I'm splitting it. So when I say split, I'm telling it what ID number to split. So in this case, I'm saying 200. So that means that this particular federation database that I'm looking at will contain ranges 100 to 200 when I'm done, and then 200 all the way up to the largest value will go into another subsequent database. So that's how splitting of databases happen, or splitting of federations. And if I connected with SQL Management Studio, you would see here that Day of Azure was my root, my federation root, but every time I created one of those federation members, I get the system GUID database that's created for me automatically. Question?
Does the splitting between the different shards happen automatically on an insert statement?
No. I'll talk to that in another slide or so. Question back there.
Real quick, does the data sync work with federated databases?
I don't have an answer. Sorry. So these databases are automatically created for me, but I'm using that use statement from here, this use federation, and then name the federation, customer federation, and then tell it which customer ID I'm interested in working with. That's what connects me automatically to one of these federation databases that's created. So I'm never actually connecting directly to system, some GUID. I'm using that use federation to more or less soft connect me to it, and then I can do my insert type of operations against that. You can get some metadata. There's sys federation distributions, member distributions. Those are all metadata type of data. So if I want to see how my ranges are broken up, you see here that the first federation member goes from this really small negative number up to 75, and then 75 to 100s in another one, 100 to 200s in another one, 200 on up is in the fourth one. So if your application needs to make a decision about which federation to connect to, it can use the metadata in this table. When you connect to a federation, in this case, I'm connecting to federation because I'm interested in customer ID 70. If I say filtering off, and I run a query, select star from customer, I'm going to get all of the rows that exist in that federation. So in this case, 50 to 75 is probably all in this one database together. If I say filtering on for customer 70, I'm only getting data where the customer ID is 70. So in this federation, remember we had customers, we had the orders, we had the shopping cart table. All of those are federated on the customer ID. So it's almost like we filter out all the other customers from this, and any query that we write with filtering on will only work with that customer 70. Likewise, when you insert data, if you need to insert a new order data for this customer 70, you would use the use federation first to connect to the appropriate federation shard, and then your insert statement is just normal insert statement after that. Does that make sense to your question about how to insert data just for a customer and make sure that it gets to the right federation? All right, so federations handle the infrastructure layer. Doesn't really help your application out. You still have to build some of that complexity into your application. My hopes is it gets better with time. Now the next thing is your connections. SQL Azure is very protective about their resources. They don't want you to start consuming resources that other people might need. So if you have your connection might be terminated by SQL Azure under a number of different conditions. If you try to just peg the service too much, they might target you or start throttling you. Long-running queries, I'm not sure how they define long-running queries, can be terminated. Idle connections, if you're idle for 30 minutes, your connection is going to be terminated. Best practice, though, how we normally create web applications is to use connection pooling on the application side. That still applies to SQL Azure. Deployment stories. So we can deploy a couple different ways. I don't know why it keeps doing that. We can deploy a couple different ways. One way is to allow Management Studio to create scripts for us. So under, if you right click on a database, go to tasks, go to generate scripts, you go into the generate and publish scripts wizard, where you can select the tables you want to export. You can tell it, how you want to save it to a single file or whatnot. Under the advanced options, though, there's a couple things that are interesting for deploying to SQL Azure. The first is, at least with 2008 R2 Management Studio, you can select script the database engine for SQL Azure or standalone. By default, standalone's marked. And if you pick SQL Azure, it will strip out a lot of the incompatibility things. If you looked at a normal create table, it's going to include things about what file group it's in and things like that don't apply to Windows Azure. So this scripting option strips those out so that they're not in the script in the first place, and you can just run that script up in Azure. The next thing is that you can actually script out your data too. This is something I didn't know until I first did this talk a while ago. And that's the types of data to script. By default, it's going to only script script out the schema. That's the create tables, create indexes, and whatnot. If you pick schema and data, you're going to get your schema, plus you're going to get all the insert statements for your data, all in that one script that you can then just run on the Azure side. There's also a tool called the SQL Azure Migration Wizard. It's on CodePlex, it's open source, and it handles a couple scenarios, SQL Server to SQL Azure, Azure to SQL Server, and Azure to Azure. So go to CodePlex, it's at SQL Azure MW, Migration Wizard.codeplex.com. Download it, install it, run it, looks something like this. It's got a set of rules built into it, defined in this XML document, that will detect things in the generated scripts that aren't supported, and then it will it'll either flag you and say that, hey, you can't deploy because you have to go and make this change, or some of these things have a corrective action that it can take instead. So you connect to your SQL server, pick the table you want to export. It goes through, it goes through its rules engines to make sure that you're not deploying something that's not going to work. And then you tell it where to deploy to. So this uses a combination of T-SQL scripting as well as BCP to actually copy the data up to your server. Have about 5 minutes left. Backups. So there's really two reasons that you want to do a backup. The first is for disaster recovery. That's, if the data center goes down or something like that, you need to restore that data. The second one is what Brian Prince calls Bob the SQL builder. And this is, the person who forgot the where clause when they were deleting. Things like that. I've never done that. I don't know about you guys. But so you need to do backups to protect yourself against non-malicious but still devastating incidents that happen. SQL Azure, if you go to that migrate SQL AzureIdeas.com site, you're going to see backup as like still the highest rated request that people are wanting. They want some kind of built-in backup mechanism, and the Azure team keeps adding more and more functionality towards that, but it's still not there out of the box. So look for that in some future release. There is one feature called a database copy that they added. And this is, you executed a T-SQL command, it starts a copy process, and you don't have to take your existing server down, and at the end of the copy process, you have a transactionally complete copy of your database at the point that it ended. So this is a way of copying your database. You might need this in a deployment scenario. Let's say you have a production database up there, you want to deploy some code up to Windows Azure in order to start testing it, and you don't want to test it against your production database, but you can make a copy of your production database and then test against that, and then when you're done, just blow away that copy that you used for testing purposes. This can also be a backup mechanism. The thing is, you have to you're copying within the same data center though, so it's not like you can use this to make a database copy between the United States and Europe. You're only working within the same data center. And the T-SQL command looks like this. It says create database as copy of some other database. And then as it's running, you can query a systable to see the status as it's going. And at the end, you'll have two databases that are identical, at least at the time that the copy ended. Last thing to talk about is SQL Azure Labs. SQL Azure Labs is the preview place for features and applications that they're working on that may or may not make it into the end product. That whole Silverlight management tool that I showed, that started as a SQL Azure Lab. That used to be called Project Dallas back in the day. So if you want to go and test some things with SQL Azure, or new functionality that they're working on, kind of the beta program, SQL Azure Labs is where you're going. Here's a screenshot of some of the things that they're working on. So we have some for some big data stuff, Cloud Numerics, Data Explorer, Data Hub. Some things that might be interested to you, go check it out. You can see where data or SQL Azure is going. And that's, I'm a few minutes early, so yes, questions? I heard hot backup and that's it.
When you create a new backup,
Yeah.
and you create it to a new database, you're doing on the cloud. So you have another account, right? They're going to charge you money for that too.
They charge you money per database consumption. So if you create a copy of a database that's running, then yes, your consumption on that second one's going to start. Yeah. So this is like electricity or anything else. This is a utility, right? So if I go and I plug my radio into another wall outlet, I'm going to get charged for that electricity because I'm using it. So the same concept here. If you use it, you're going to get charged for it one way or another. Question?
You mentioned ISV hosting software and possibly management, isolating accounts and isolating usage.
As one scenario for doing this.
Yeah, so I haven't seen that quite exactly. Can you elaborate on that?
Again, Azure is more of the building blocks. So a lot of the things that an ISV might do for multi-tenant applications would have to be handled at the application level, or maybe they would have multiple websites, web applications set up on boxes that point to different SQL Server databases as they need to. So that's one way to handle multi-tenancy.
It inherently facilitates that.
There's not, unless you look at like federations as one mechanism, so that this customer is in this one federation member, another customer is in another federation member. So I think the direction is to head down that way, but right now you have to do a lot of that in your own application.
So the federation is within one database, right?
Yes, your federation, well, it's creating multiple databases for you, but logically they're working as one database.
So if you need to shard because your data is bigger than 150 gigabytes, then you're talking about sharding across multiple Azure databases, right? You need to have the connection strings for the different physical, like, or actual Azure databases.
My understanding is that there is a valid reason to federate a database for what you just described. He said if your data is bigger than 150 gigabytes, so you have to start moving into other databases. And I think the federation story applies there because you could start up another federation to handle the overflow over 150. So you're dealing with two databases there. The server's not restricted to 150, it's just individual databases. So as it created those databases, let me find that screenshot. As it created those databases, well, you can kind of see it here. As it created these system databases in here, I think each of those apply to the same restriction that was set up for the database that I'm federating on. So if I define that database to be a 5 gigabyte max, then each of my shards can be 5 gigabyte max. Or if I define that database to be 150 gigabytes max, each shard can be 150 gigabytes. It's not like it's going to restrict the size of a shard, so that the sum of all of them adds up to 150. It's each one inherits from that, the definition of that first master. Question back there in the back.
If there is a problem cloud infrastructure itself in the data center where you have your affinity group,
Like if somebody writes a leap year detection code and it brings down the cloud? Just hypothetically saying, yeah.
is there any recourse to the throttling that you might experience in your SQL calls to change database centers, or do you just kind of have to, in those few circumstances, just ride it out?
Yeah, well, I think this gets down to SLA question. And their SLA for SQL Server, I think, is 3 nines. And then you have they have a contractual obligation. You have recourse if they don't meet the 3 nines. So I don't think that's a technical issue unless you plan to have your data somehow migrated or mirrored in another data center so that you have that on-the-fly failover. It's not something that they automatically provide. I think you're just going to have to take an outage in that case. The easiest solution is to take an outage, apologize to your customers, sue Microsoft. Question?
This is regarding the type of applications that we deploy to Azure. Can we deploy all Microsoft applications like Star, SharePoint, or do we have any limitations? Only certain applications can be deployed.
Well, that's a Windows Azure question in general. I don't know that I have the answer to that, but I'm sure if you go find somebody else in the next session where he's talking about Azure architecture and whatnot, that's probably a better person to answer that. From what I've seen, though, a lot of things won't work just by deploying them.
So in federation scenario, how insert strategy works? We have 4 databases, right? It's primary key will suppose identity column. Next time. How it goes, where to insert?
Well, when you have a federated database, you have to use the use statement.
But we don't know, right? What is the last step? I mean, the federation will give the range there, right?
Right. So if you have a new customer, how do you know which one to connect to?
Correct. That's what this question I think asked.
I think you can use it. You can certainly use the metadata table, like on the screenshot that I'm showing here. You can query to see which federation that would go into, and then you can connect to that the highest federation by using any number in that range.
But this is only saying the range, but we don't know what is current running number.
Right, but you know that the next one's going to go into the highest range.
Oh, we have to get max plus again into the range. Because it's already
Well, like in this screenshot, we see that 200's in the highest range. So I can connect using any arbitrary CID. I can say 3000 or something because it's going to be in that same federation. And then when I do my insert, I don't have to insert for that one specifically. I can just say an insert and then read back the number, and then I would know it. The point is you want to be connected to the federation that's going to handle that number.
Or you could connect with the idea of quintillion.
Right, because everything above 200 is going to be in that last federation until I split it.
It's 2 separate processes.
Yeah. Unfortunately, I don't have much better guidance on using federations beyond this. Last question, and then I'm out of time.
So you told us SQL Azure dropping lots of additional lot of stuff, right?
I'm sorry?
Since jobs, can you schedule the jobs on SQL Azure side?
I don't think there's a SQL agent running, so you don't have the same types of job capability that you would have on-premise.
SSIS, all other stuff is not running.
Well, you can run something on-premise on your own desktop or whatever that would automate SQL Azure, but scheduling something in SQL Azure isn't something built in. That's one of the feature sets because there's no SQL agent that you have access to schedule that job. Last question.
You said that you can have your connection drop for excessive resources. Will it keep you from connecting again? Like if you just
No.
have a lot of stuff to do.
No, just keep trying again. So if you get dropped, it's because you were picked to be dropped. Just try again. All right, thanks everybody.